Hello everyone, before starting this lesson, try the warm-up. Factor fully and complete the square. So pause the video and try these questions. This is a simple trinomial, so we need two numbers that multiply to -3 and add to 2. Those numbers are -1 and +3. So the factored form is x minus 1 times x plus 3. There is no greatest common factor between these three terms, so this is a complex trinomial. We need two numbers that multiply to 2 times 2, which is 4. So multiply to +4 and add to -5. Well, those numbers are -1 and -4. So -5x decomposes into -1x minus 4x. We factor by grouping, and we end up with 2x minus 1 and x minus 2 as the two factors. When we complete the square, remember whatever the leading coefficient is, we make that a factor for the first two terms. Now, half of this is 2.5, squared is 6.25, so we have to add 6.25 to make a perfect square trinomial. But we just changed the equation, so to make it unchanged, we have to subtract the same thing. Factor the perfect square trinomial, we get this. Expand, we get this. And simplify, add your like terms together. And this is the vertex form. So those are the algebra skills we've talked about so far, is factoring and completing the square. The next thing we're going to talk about in this lesson is solving quadratic equations. So now we're going to have an equation we need to solve for x, basically. There's three ways to solve a quadratic equation that we're going to talk about. So our goal is to solve quadratic equations by graphing, by factoring, and using the quadratic formula. So those are three different ways we're going to look at today. So here's an equation that I want to solve. 3 is equal to 6x squared minus 7x. Now this is hard to solve by guessing and checking, which some of you might rely on to solve equations, because this is squared, this is not, but it's the same number, and it can be hard to do that way. So I'm going to show you how you can actually solve this equation. First, I want you to notice this. If I subtract 3 from the left-hand side, I end up with 0. But if I do that, I change the equation. So I have to do the exact same change on the right-hand side. So I end up with 6x squared minus 7x minus 3. Now you might be wondering, what is the purpose of that? How is that helpful? Well, if I graph y equals 6x squared minus 7x minus 3, I can locate on the graph where y is equal to 0. So I used a graphing calculator and I graphed the function here, y equals 6x squared minus 7x minus 3. This is the graph I get. And where does y equal 0? Well, at these 2 points, the x-intercepts. Right? When on the y-axis, when y is 0, that's when we're on the x-axis. So when x is -1/3 or positive 1.5, those are the answers to this equation. So the way I write my answers is, well, x can equal either one of these two numbers. Notice I'm using my set notation with the curly brackets. X is equal to either of these answers. So yes, I've solved the equation and there's more than one answer. But that's okay, because remember, you can have more than one x-intercept. You can have more than one answer to an equation. These are called the roots, or the zeros, as well as the x-intercepts on the graph. Notice you can have two possible answers. You can have just one answer, or you might not have an answer for the equation. You might not be able to solve it. That would just be a graph that has no x-intercepts. So if you need to solve a quadratic equation by graphing, just make the equation equal to 0, then graph the function and see what the x-intercepts are. And those are your answers for x. I'm not going to spend any more time on solving by graphing. The majority of the lesson is going to be focused on solving in other ways. But before we get into these other ways, we need to walk through a basic mathematical principle here. I'm sure you know the answer to this. 5 times 0 is 0. And I'm sure you know what 0 times 9 is. But do you know what this is? 3 times something equals 0. Well, it has to be 0. If the answer is 0, this has to be 0, because 3 times anything else will not be 0. Well, what about this? Something times 57 is equal to 0. What's here? What is that number? Oh, surprisingly, it's 0, because 0 times 57 is equal to 0. All right, but what if this is negative? A negative 45 times something is equal to 0. What does this have to be? I think you've caught on now. It's 0. Look at all this. Everything I wrote was a 0. If you multiply anything by 0, the answer is 0. If you're multiplying two numbers and the answer is 0, well, that missing number must be a 0. This is an illustration of the zero product property. If A times B equals 0, then either A equals 0 or B equals 0, or both. Keep this principle in the back of your mind as we go through the next example. We're going to solve the equation. X plus 2 times x minus 3 equals 0. Now we can actually use the zero product property to answer this question. Remember, if two numbers multiply together and the answer is 0, then either the first number is 0 or the second number is 0, or they're both equal to 0. So if this is the question, x plus 2 times x minus 3 equals 0, then we can say either x plus 2 is equal to 0 or x minus 3 is equal to 0. Now, if x plus 2 is equal to 0, then x equals negative 2. But if x minus 3 equals 0, then x equals 3. So I hope you can see that these are both answers to this question. What is x when we solve this equation? Well, it can be either negative 2, because that would make this equation equal to 0, or x can be equal 3, because that would also make this equation equal to 0. So we can write our final answer like this. X is equal to negative 2 or 3. That's how we can write it in set notation. So we use the zero product property to solve this equation. Now it's your turn. Solve each of these equations. Do it the way I showed you in the previous example by using the zero product property. Pause the video, try it, and see how you do. All right, you can check and see how you did. If this was giving you trouble, you should pause the video and get some help before you move on to the rest of the lesson. We're going to change a little bit here. This time, we're not given the factored form in our equation, and it's not equal to 0. 3 is equal to x squared plus 2x, and we're to solve by factoring. We're going to use the zero product property, so we need this equation to equal 0. So I'm going to subtract 3 from the left-hand side, which turns it into 0. And I do the same change on the right-hand side, which makes it into x squared plus 2x minus 3. Now that I have an equation equal to 0, I'm going to factor what I have over here. This is a simple trinomial. I need two numbers that multiply to negative 3 and add to positive 2. Those two numbers are minus 1 and positive 3, so this is the factored form. Now I have two factors multiplied together, getting an answer of 0. So I can use that zero product property. X minus 1 is equal to 0, or x plus 3 is equal to 0. Now I solve the equation in each case. Well, if x minus 1 equals 0, then x must be 1. If x plus 3 equals 0, then x must be minus 3. So if x can equal either one or the other, then I can write my final answer as two possibilities in set notation. X is equal to negative 3 or 1. So we got to rearrange the equation to make it equal to 0, then factor, and then we use that zero product property to solve. So now it's your turn. Solve by factoring. Solve it the same way that we did before. You might need to remind yourself how to do some of the factoring, but same principle. Make it equal to 0, factor, use the zero product property. Okay, pause the video and try this on your own. Remember to make the equation equal to 0 first. If you didn't do that, you might want to pause the video again before you proceed. This is a simple trinomial. We factor it. X plus 4 equals 0 or x minus 6 equals 0. If x plus 4 equals 0, then x is negative 4. If x minus 6 equals 0, then x is 6. Two possible answers for x. In the next one, this is a complex trinomial. So we're going to decompose the middle term, factor by grouping. 2x plus 5 times 2x plus 5 equals 0. Well, 2x plus 5 could equal 0, and the other option is the same thing, so we're only going to get one possible answer here. 2x plus 5 equals 0, which means 2x must equal negative 5. And if 2x equals negative 5, then x must be negative 5 divided by 2. Or I can just leave it as the fraction negative 5 over 2. This is a difference of squares. So I have 3x plus 5 times 3x minus 5. If 3x plus 5 equals 0, then x is negative 5/3. But if 3x minus 5 equals 0, then x equals positive 5/3. So I can just write that like this. X is equal to plus or minus 5/3, because it can be negative or positive. Now, if you had trouble with any of this, you should pause the video and get some help before you move on. We're going to solve by factoring in this example again, and we're following the same principle. So we need to make sure that our equations are equal to 0, and then we factor, and then we use the zero product property to solve for x. So pause the video and try these now. To make this equation equal to 0, I'm going to subtract 5x and subtract 1 from the right-hand side. 5x minus 5x is 0, plus 1 minus 1 is 0. I do the same change on the other side. 2x squared minus 5x, and then plus 3 minus 1 simplifies to plus 2. So this is my equation equal to 0. I didn't show all my work here because I was afraid I was running out of room. But this is a complex trinomial, so I decompose the middle term, and this is what I end up with the factored form. If 2x minus 1 equals 0, then 2x must equal 1, which means x must equal 1 over 2. And if x minus 2 equals 0, then x must be 2. So there's two possible answers for x. When I factor this, 2x is the greatest common factor. I'm left with x plus 3. So 2 times x plus 3 equals 0. So x equals 0 or x plus 3 equals 0, in which case 0 or minus 3 are the two possible answers. And for the last one, when I make this equal to 0, I end up with 3 as the greatest common factor and a difference of squares, which I can factor to get x plus 5 times x minus 5, in which case x must equal plus or minus 5. So, if you're solving an equation by factoring, you need to make sure the equation equals 0 first, and then factor, and then use that zero product property to figure out what the answers for x are. Now I want to show you another way that we can solve an equation. We can solve by completing the square. So if you'll recall, completing the square is turning standard form into vertex form. So I use the lead coefficient as the common factor for the first two terms. Then I create a perfect square trinomial. Half of 8 is 4, squared is 16, so I have to add 16. But to avoid changing the equation, I have to take it away as well. This is a perfect square trinomial right here. And when I factor that perfect square trinomial, I end up with this, x plus 4 squared. Now that minus 16 is still there. And then I have to expand and simplify to get the vertex form. So when we completed the square before, this is how we did it, and this is what we're going to get. But we're going to solve now. We have to solve the equation. We have to figure out what x is equal to. Well, let's start moving things around. Let's rearrange this equation. If I add 50 to the right-hand side, I eliminate this term, but I have to do the same change on the right. So if I add 50, I get 50 equals 2 times x plus 4 squared. Now this is times 2, so the opposite would be divide by 2 to get rid of it, and I do the same change on the other side. 50 divided by 2 is 25. So 25 is equal to these brackets squared. So something squared is equal to 25. Well, just over here, I'm going to think out loud. Something squared is equal to 25. Well, it could be positive 5 or it could be negative 5. So that's where that plus or minus sign comes in. X plus 4 must equal either the positive square root of 25 or the negative square root of 25. They will both work because positive 5 squared is 25 and negative 5 squared is also 25. So now that I know x plus 4 is equal to either positive or negative 5, to solve for x, I have to subtract 4. So negative 4 plus or minus 5 is what x is equal to. So all this means is that I have to calculate twice, once with plus and once with minus, to get what my possible answers are. Negative 4 plus 5 is 1. Negative 4 minus 5 is negative 9. So that's how I can get my two possible answers for x. The way I got it was I completed the square. Now, I don't know about you, but this is quite the process here to complete the square and then start doing algebra to solve for x. Well, if we completed the square using this general form, like I'm showing you here, we end up with this equation. Now, don't get afraid. I'm not going to ask you to duplicate this on a test. I'm just showing you that using these placeholder symbols, A, B, and C, I can complete the square the same way I just did in the previous example, and when I solve, I end up with this. And that is what we call the quadratic formula. So the quadratic formula is to solve for x in an equation that's written like this. Standard form equals 0. So if you have an equation in standard form equal to 0, you can plug in your values for A, B, and C into the quadratic formula, and you can use your calculator basically to solve for x. You don't have to do any factoring, no completing the square. It's basically a shortcut to solve equations. And this will work for those equations that you can't really factor, but still have a solution. So let's go through this. Can you solve x squared plus 6x plus 4 equals 0 by factoring? Well, let's think through it. This is a simple trinomial. I would need two numbers that multiply to 4 and add to 6. Well, if we think about all the numbers that multiply to 4, it's 1 and 4, or 2 and 2. Well, those don't add to 6. So we can't factor this, but we need to still be able to find the solution. Well, good thing we know the quadratic formula, because we can solve this equation using the quadratic formula. As a reminder, this was what the formula was. X is equal to negative b plus or minus the square root of b squared minus 4ac, all of that divided by 2a. Sounds complicated, but it's really not too hard. Remember, we need to have our equation in standard form equal to 0, and that's what we have right now. A is equal to 1, B is equal to 6, and C is equal to 4 in this equation. So I'm just going to replace B with 6 wherever I see it. I'm going to replace A wherever I see it with 1. And I'm going to replace C with 4. Now I've updated the quadratic formula, and now I just proceed to evaluate. I recommend you look at what we call the discriminant. That's the part inside the square root symbol. I would say do that first. 6 squared is 36, and you're subtracting 4 times 1 times 4, which is 16. So 36 minus 16 is 20. This is the square root of 20. And 2 times 1 is 2, so I can simplify that. This is what I'm going to do for my calculation. I'm going to do the calculation once with a plus sign here, and once with a minus sign here. And I'll get two different answers for x. So I do negative 6 plus the square root of 20, get that answer, and divide it by 2. And then I do the calculation again, negative 6 minus the square root of 20. Get my answer, divide that by 2. And if you're doing it right, you'll get these two answers for x. And we can write the final answer like this. Now, the numbers are not nice integers like we usually like, but that's because, remember, we couldn't factor this, so we're not going to have nice numbers. I recommend you try doing this calculation to see if you actually do get these answers before trying to do the next examples on your own. And if you don't get the same answers, you should reach out for help before you move on to figure out what the issues are, probably as you're inputting this into your calculator. But if you're good with it, try these. Remember, the equation has to equal 0 first, and then you can use the quadratic formula. So pause the video and try these on your own. Remember, if you're doing it right, your equation equals 0 first, so you should have these. If you need to pause the video again to see the rest, you should do that now. All right, if you're doing it right, you should be getting these answers. And if you're not, you should reach out for some help. Some common issues: when you're squaring a negative, that's positive. Here you have a minus, and you're multiplying by another minus. So you're actually going to be adding. This is going to be 49 plus 72. Another common issue is forgetting to calculate the numerator first and then divide by the denominator. If you do it try to do it in all in one step and you don't put brackets around the numerator, your calculator might get confused. These are just a couple of little things. If you're still not sure, you should reach out for help before you move on. Now, just to add on to all this, you can actually know how many solutions you're going to get based on the value of this, what we call the discriminant. The discriminant is the part that's underneath the square root sign in the quadratic formula, b squared minus 4ac. If that discriminant is a positive value, then you're going to get two real solutions. You're going to get two answers for x. That makes sense because you're going to get the positive square root of that number and the negative square root of that number in your calculation. So you're going to get two answers. Now, if that discriminant is equal to 0, well, the positive square root of 0 is 0, and the negative square root of 0 is 0. So you're going to add 0, or you're going to subtract 0. That ends up being the same thing. So really, you're not going to get two answers. You're only going to get one answer to the equation. You're going to get one real solution. And if that discriminant is a negative value, well, can you take the square root of a negative number? No, you can't. So if you end up with a negative sign in here, it would mean that there are no solutions to your equation. It just means you cannot solve that equation. Now, just so you know, if I ask you to solve an equation, you shouldn't be getting this. You shouldn't be getting a discriminant of a negative number. If you do, you're probably doing something wrong. If the question is phrased, solve if possible, then perhaps you won't be able to solve the equation. But if I just say solve the equation, I'm going to get you to safely assume that you can solve it. So just double check every time. If you're getting a negative answer underneath the square root, just double check that your signs are correct. And this last example in this lesson is just to get you to put a few ideas together now. This is an application of a quadratic function. The path of a basketball is modeled by the function h of d equals negative 0.25d squared plus 2d plus 1.5, where h is the height and d is the horizontal distance, both in meters. So h of d, remember that's the height as a function of distance. The height is equal to this calculation. So if we know the distance, we can calculate the height. Or if we know the height, we can calculate the distance. How far did the ball travel horizontally when it landed on the ground? So you have to think, when it landed on the ground, what was the height? That will help you determine where to put that number in the equation and solve for the horizontal distance. Part B, determine the horizontal distance, so calculate D, when the ball reached a height of 4.5 meters. So here we know height, we're calculating distance. And lastly, what was the maximum height of the ball? You have to think about where that would be on the graph and how to find that point. So we're putting some ideas that we've talked about in previous lessons together with what we talked about in this lesson. So you can pause the video and see how much of this you can do on your own. For the first part, it's asking us how far did the ball travel horizontally? Well, that's D. We don't know what it is. When it landed on the ground, well, the height is 0 on the ground. So if we know the height is 0, replace the height with 0, and we can solve for D. I chose to use the quadratic formula because that just kind of looked too hard to factor, so I just plugged my numbers in for A, B, and C in the quadratic formula, and I got these two answers, negative 0.7 and 8.7, as my two possible values for the distance when the height is 0. However, think about this. Does that first distance actually make sense with the context? Not really. That would mean it's behind the person who was shooting the ball. That's what a negative distance would mean. So back here, basically. If I extend this backwards, that would be negative 0.7 meters away from where it was fired. But he's going to shoot it forwards. So we're only going to look at forward distances. It's going to be 8.7 meters away. Part B, determine the horizontal distance when the ball reached a height of 4.5 meters. Well, this starts off the same as the previous question. We know the height. We want to find the distance. So we plug our value for height into the equation. Height is 4.5 meters. But now we have to solve for distance. This is where it gets different. In the part A, it was already equal to 0. Here, it's equal to 4.5. I have to make it equal to 0 first. And once I do that, then I can use the quadratic formula like I did before and get my two possible answers. So I get 2 and 6 as the possible answers for the distance. Now, in the first question, part A, I said that this one did not make sense, so I only gave one answer. Am I going to do the same thing here? Well, do they both make sense? Let's see. He shoots the ball forward. When the height of the ball is 4.5 meters, does it make sense that it would reach that height at two different horizontal distances? Well, 2 meters away, and again at 6 meters away. That makes sense. On the way up, it reaches the height of 4.5 meters, and it reaches that same height on the way down. So both of these answers actually do make sense this time. So I can say the ball reached a height of 4.5 meters when it was 2 meters away, and again when it was 6 meters away. Now the last question, what was the maximum height of the ball? Well, I updated a little drawing up here to help you visualize this. The maximum height of the ball is at the top of the curve. That's the vertex. We need to find the vertex in order to find the maximum height of the ball. Well, we've done some work already. We know that this curve is going to be symmetrical because it's a quadratic function. So it's going to be symmetrical across the axis of symmetry. And the axis of symmetry is going to be right in the middle. So the axis of symmetry is going to be halfway between 2 and 6, which is 4. I could also think of it in terms of halfway between the two x-intercepts. Either way you do it, it's at 4. So the axis of symmetry is when the distance is 4 meters. So I know it's going to reach the maximum height when the distance is 4 meters. What is the maximum height? Well, good thing I have an equation. I can figure that out. I know what D is, put it in where D is, calculate what the height is. So when I do that, I get 5.5. The height is 5.5 meters. If there were certain parts of this that did not make sense to you, you should reach out for help. Otherwise, it's time to practice. So you need to know how to solve equations by factoring and using the quadratic formula in order to be successful with these practice questions. If you're getting stuck on anything, you should reach out for some help, and I'll do my best to help you.